Hey Techno Studs! In this video, we're going to talk about IPv6 address types. When it comes to address types, IPv6 did things that were quite a bit different than IPv4. IPv4 had broadcast addresses, they had unicast addresses, and multicast addresses. IPv6 has some of that, but they do things a little differently. So let's jump into it and let's talk about IPv6 address types. In this video, we'll start out by just taking an overview look of the different address types. Then we'll jump into what a unicast address is, what a multicast address is, what an anycast address is, and there's a couple other addresses that we'll throw in there as well. Here are some of the different address types that we have for IPv6. Now, one thing that you may notice is that there is no broadcast when it comes to IPv6. It's not listed out here because it doesn't exist with IPv6. IPv4 had a broadcast where a machine would send out a broadcast and then that would be sent to all of the machines on the network. IPv6 does have something similar, but it comes in the form of a multicast address, not a broadcast address. One of the things that IPv6 attempted to do was to get away from broadcasts on the network. Okay, so what do we have? We have a unicast, which is just like IPv4, where you got one machine that's talking to another machine and they're sending messages back and forth. You've got a multicast, which is just like IPv4, where you have one machine that's talking to multiple machines at once, but not all of the machines. It's not a broadcast. And then you have this new one called anycast. And anycast is interesting. So there's several machines that will subscribe to the anycast group, and then when a message is sent to that anycast address, then what will happen is that message, that request, will only be sent to one of those machines, not all of those machines. See, multicast is one to many, but it's sending it to all of the machines, where anycast is going to send it to the first available machine that responds. So it's only going to be sent out to one of those machines and not all of the machines, and that's anycast. With each one of these types, there are other types as well. The ones that we're going to be going over is that globally unique address, a unique local address, and link local address. So just know that there are subtypes to these types. A globally unique address is one that can be routed on the internet. So a device would get a globally unique address that would be good for traversing the network and going out to the rest of the world, that the rest of the world would know how to route back to that globally unique address. Then we have a unique local address. A unique local address is within your own network here. So it stays within your own network. And so it's very much like a IPv4 private address, except for it's not globally addressable and you can't be translated. So it's never intended to go and be able to go out to the outside world with that address. It's only intended to be used internally. Then we have our link local addresses. Our link local addresses are just supposed to be local. They're not supposed to be routed at all. What that means is that these are layer 3 devices. And this is a local area network right here. This is a local area network right here. So a link local address is only meant to be used internally with this link local address. You're only going to be able to communicate within the devices that are in the layer 2 reach within your device. It's interesting. So IPv6 set out to do away with some things that IPv4 did. It wanted to do away with things like a DHCP server. It wanted you to be able to connect to a network for a network interface to be able to determine its own IP address and start being able to communicate with its own IP address and then be able to discover information to get out to the rest of the world. And so in order to facilitate that, they came up with this link local address. and as I mentioned, it can't be routed externally. It has to be configured on every interface, or it's actually automatically created. If it's IPv6 interface, then it's going to automatically be created. And it's used to discover things on the network. So it'll start discovering ways of communicating on the network. And that's randomly generated. We'll talk about whether it's randomly generated or it could use EUI64 to generate it, and we'll get more into that as well. Here's a table that we're going to start filling out. We've been going over these different types of addresses, whether it be a globally unique address or a unique local address or a linked local address. Well, they're assigned to certain ranges. And so we see that the globally unique address has things starting out with a 2000/3. So the first 3 bits, if the first 3 bits is 0, 1, 0, then it's going to start everything from 2000 to 3FFF, and you can see all F's there. So really, it's a huge address space, huge, at 2 to the 125th power. So it's a massive address space for those. Unique local is also given a little bit smaller range, but still a really large range here. And the link local address is a little more zeroed in here. You only got 2 to the 64th bit here of playroom with this, but that's all we need because that represents a ton amount of machines. So here are the ranges. We're going to fill in the rest of this chart. We're not going to get real in-depth into multicasting, but IPv6 definitely takes multicasting to the next level. So multicasting, remember, is when one device is talking to multiple devices on a network. There is one multicast address that I will mention that is a all nodes. So it's not a broadcast because it's not just sending it out to every device that's plugged into the network. But most devices are going to check in and subscribe to the all node multicast network. So most devices are actually going to receive messages from this all node multicast address. So there is that's IPv6 form of broadcast, but it does work a little different than an actual broadcast. And we can see too that multicast has its own range as well, and it's quite a large range. So that is something that you'll see out there often, this FF00/8. Anycast is one of those unique aspects of IPv6. As mentioned before, it's much like multicast, where there's multiple devices that subscribe to that anycast server, but only one of them is going to get the request. Let's say there's some sort of service that you are delivering and you want multiple devices to be able to deliver that service. Then multiple devices could possibly check in and say, hey, I'm available for requests going to this anycast address. So then when this machine makes a request to that anycast address, the closest machine, the one with the least cost, is going to be the one that ends up responding. So rather than it being sent out to all of these devices, it's only going to be sent out to the device that is closest to you, allowing us to free up quite a bit of compute space and bandwidth and things that are unnecessary. So we save on resources by these anycast addresses. A few other ranges that I want to call out. This is by no means an exhaustive list of ranges. You can go and do a search online, look at a wiki article. There's a lot more ranges. These are the ones that I just want to point out here. We talked about the globally unique address, a unique local, a link local address, a multicast, the host loopback. This is similar to a 127.0.0.1. It's just ::1/128. So that's when it's referring to it itself. Then we have a unspecified range, something that's not specified. And then we have the all route or the default route or the everything that represents everything. This is similar to our quad 0 when it comes to IPv4. So there's a few other ranges when it comes to IPv4 or IPv6. In this video, we briefly went over those different address types. Then we got more in depth into what a unicast address is, what a multicast address is, anycast address, and then we wrap this up by talking about a few other types of addresses when it comes to IP version 6.